you thought that you presented in such a clear way.
We tend to hear what we expect to hear and see what we expect to see. So when a child comes into a classroom, they have some ideas about how the world is working. They tend to attend to the things that the teacher says that fit with their previous ideas and sort of ignore the things that don't.
Yeah, I'd like you to take a look at it and trace those lines down yourself and examine it carefully. It might be a little sharp on the edges.
Oh, I was wrong. Oh, wait a minute. Well, one of them's connected to the side, to the metal on the outside. Yeah.
Okay. Do you think that's important, that one goes out to the side?
Yeah.
Jennifer finally realizes why her previous ideas are wrong and creates a new drawing that is 100% correct.
And one of them to the side.
Well, you said it wouldn't work last time. What do you think?
I don't think it'll work, but
Could you draw in what you think you need to add to this to make the light bulb light?
just a little case.
For some reason, Jennifer still doesn't believe her drawing is correct and insists the bulb can't light without the socket.
I'd like to try out the drawing that you did. I'll hold the light bulb, I'll hold the battery. You can tell me what to do.
He's up to each end of the battery.
But before we attach it, I want to know whether you think it's going to work or
No.
not. And why do you think it's not going to work?
Because I think you need the pieces to carry the charge. I don't think it'll work just connecting the line to the light bulb.
If it did work, then what would you think?
I fall off my chair.
Okay, all right, let's see what happens.
Oh my god. Oh, work. I don't know, I guess you don't need the little pieces. That's probably just to hold it in.
Our optimism about what children ought to be able to do stems perhaps from rather deep-seated views about learning, and that as long as the expert tells the story clearly and that the person who is learning is listening and paying attention, then they will automatically build up the understanding that the expert has. Now, all our current knowledge now in cognitive science and in cognitive psychology and in science education is telling us that that simply does not happen. Children may well be listening, paying attention to what is being said or what they're reading in the book, but they are constrained in different ways to the ways that the teacher intended. And that is the issue that we have to deal with.
You were the physics teacher, and you were going to teach a lesson on electricity. What would you have done with the students?
I'd start with the inside of the light bulb and work my way out. So I'd explain everything.
Did I explain this to you?
No,
So how did you listen?
I just figured it out. I just looked at it. After you look at it, you can see that what happens. It's kind of obvious if you just look at it.
All right, so that's the second clip. So can we bring the lights back? So with that in mind now, what was surprising to you after watching these two clips? What was interesting to you? Anybody care? Sure? Yeah.
I found it interesting that they said that this is a problem now. Like it hasn't been, but I feel like teaching has always been that kind of way, that it's always been a problem, and it can continue to be a problem, that it's not just coming up out of the blue and figured out.
Mm-hmm. Very interesting, yes. Anybody else? You want to share what was interesting to you? Yeah.
I found it interesting that like when more technology is added to the classroom, it actually confused the student more, like the socket holder.
Ah, yes. Good idea about the socket. Anything else? So yeah, if you watch these two video clips and you really think about it, there's actually a lot of little interesting pieces that kind of come into play. One is the technology. One is the issue about, isn't this a problem that's been and still is a problem? And my answer to that is, yes, it is a problem that still is ongoing today. A lot of it is that we've now only become to recognize what it takes for a learner to learn a situation or an idea, but how we frame that learning experience has always been a continuous challenge. Especially if you think about the nature of a learner, at that time may or may not have the same experiences or access to information as students of today. Okay, so we're talking about now Generation Z, when sometime back we were talking about millennials. And now we're talking about the differences between millennials and Generation Z and what access of information that they have and how they're bringing in technology and all this other stuff. And that kind of connects to the idea of technology. Well, okay, this technology of having some kind of plastic holder, and that somehow there's has to be a real meaning for that. Well, that kind of comes into this idea that sometimes we might accidentally introduce unnecessary information necessarily. Students are going to come in with ideas. We might show them, or through their own inquiry, other ways of thinking that we're trying to guide them to a more scientific appropriate idea of how to light a light bulb. But sometimes because they have this really definite belief or experience that you still have to have the socket, still has to come in, those ideas can be really hard to change sometimes, and we have to be mindful of that. Sometimes those beliefs and ideas, despite giving you a situation where it's going to maybe conflict your thinking or way of believing, it can be really hard to change. And so we have to take these ideas that they're working with and grappling with and give kind of the next closest extension and the next closest extension. Hopefully extend their ideas such that it becomes more appropriate. You had a question in the back. Yeah, so actually I'm not aware of how they picked the said best student in the classroom, but you are right. That is actually an interesting point as what does it mean by best? Best at what? Doing paperwork, or is it best listener? My presumption was it was identified by the teacher as a person who seems to be most attentive and best marks in class. But even still, if you're just going to say somehow this was qualified as the best, they too have difficulty changing their ideas. Despite that teacher is lecturing to them, presenting them ideas, the presentation alone is not enough. And it also didn't fully sway this idea of you don't really have to have the socket. And you could still make the light bulb light without that. So just to kind of take away some of the big ideas from this video set. Now, obviously, this whole video series is really long, which we didn't have time to go through all of it today, but you are welcome to do that online. It's free. But the main idea here that we can take away at least is one, we have to listen to students. Of course, the question becomes, well, how can we do this? But when you're saying listening to students, it means that you're kind of getting a sense of the learner. Meaning, if I'm going to be doing a lesson for an undergraduate versus a middle schooler, each one of them are going to have very different experiences, different knowledge sets that they're going to be working with. So I have to tune my lesson such that I am kind of listening to them, what they're able to bring. Okay? So it might be the language, how you phrase words. That could be very different than how I would do it for an undergraduate. Okay? You also have to listen to them sort of in the form of an assessment. Allow them to do the talking. Okay? That's going to inform you as the instructor or the teacher as to where are they at in the learning moment now, and then how can I frame them sort of such that you kind of not tell them, but you allow them to guide in their inquiry process to a more appropriate understanding. We also need to motivate your students. Okay? So it's not enough just to sit there, you used to remain static, and information is being poured into you. You're not an empty vessel. But to motivate you by taking what interests you, what you already know, and thinking about how can we extend those ideas. Okay? So the question then becomes, how can whatever you want to learn, whatever topic it is, be used to motivate your learner? Now, keep in mind, the activity that you did, yeah, there's college graduates out there who still struggle doing that activity. But this activity has also been done in also elementary classrooms. The heart of the issue, though, is the manner in which you do the activity. Okay? So obviously, if you're in an elementary classroom, you're not going to frame the questions and the inquiry process necessarily in the same way as you would as an undergraduate. But you can still allow them to explore and get a sense of ideas. For a novice elementary type student, we'd probably be looking at what kind of rules or patterns can we observe. Whereas at the undergraduate classroom, we're going to be going even further. I'm going to have you do measurements, measure resistance, measure voltage, measure current, and see about building a more coherent idea, concept. Ohm's law, for example. Okay. Now, the main basic tenets when you think about a learner is, one, a human being is going to come to a learning experience without prior knowledge, skills, beliefs, and the concepts that might influence the learning process. Okay? So that was kind of what we shared out earlier when I asked you, so what were some of the things you were thinking, or what were the ways you were thinking when you were predicting, or when you were actually doing the activity? You weren't relying on me giving you the directions on exactly what to do. There was something about what you were doing that was being informed by some other ideas that you had. And an essential part of the learning process is the learner expending the mental energy. You do not want to make it where it's a lesson where it's this cookbook and they don't really have to think about step by step what they're doing. They're just kind of flowing through the recipe. Instead, you want them to get them motivated. You want them getting thinking about why it is I'm going to do this next step, or maybe let me explore the ways in which I want to go into my inquiry. Okay? Maybe you guide the students in such a way that you allow them to do the exploration themselves. Now, there's other information out there kind of informing instructors, teachers on how students learn. One such is obviously the book, How Students Learn. That's from the National Research Council. But from that, we can also derive some other basic tenets. And this is also really kind of comes from the last segment of the video that we just watched with the last speaker. And that kind of boils down to basically, we need to listen to our students, but thinking that students are listening to us alone is not necessarily enough. It just doesn't happen. By thinking that people are listening to me, even if I'm going to give a very perfect lecture, they may not necessarily be learning. It's not enough. And so we also have to understand that students are going to be constructing knowledge in different ways. By, let's say, for an example, students working on, here's a topic, once you go solve some problems. That may not be enough for them to still understand that topic or the concept. Maybe they need to go into a laboratory environment and actually do some investigations around that. Okay? There's also different ways of thinking. So maybe you can understand a topic by just looking at it in a mathematical equation. Maybe that's enough for you. But for some people, maybe a graphical representation or a drawing is going to help best represent the idea or the topic that you're tackling. And again, you need to pay attention to what knowledge are students going to bring to the classroom, because that is what's going to allow them to refine those ideas and build more on top of that. Now, unfortunately, in our educational system, we have a lot of homeworks and so forth, but we don't really have a lot of leeway for failure. And actually, failure is where we really learn. It's one of those things of, go out there, you do an experimental design, and it did not work. But unfortunately, you don't have time necessarily to go back, as we should, to say, okay, what worked about that design? Evaluate it. Pick it out. Fix the pieces that need to get fixed, that you think about why you're going to fix those, and see if it works again. That's where we're really building our knowledge, through that revisionary process. And the other basic tenet, really, is to develop competence in an area. A learner needs to be able to have a deep foundation of the knowledge, understand the facts and ideas behind it, and organize that knowledge in a way for retrieval and application. Okay? So not only do you know the knowledge, but kind of basically the ideas behind it. Why is that knowledge relevant such that you can access it in very easy ways? There's also kind of some other principles from cognitive psychology, cognitive sciences too, that can inform instruction. One is the Constructivist Principle. All right? This is basically just tells us that we build our knowledge. We connect knowledges from one idea to another. We extend knowledge. Context principle, that just tells us sometimes we're dependent upon context in which we learn. So maybe I'm really good at solving a motion problem where the motion is just along a horizontal plane. Okay, maybe I'm really good at that. But now the context is going to change if I ask you to solve a problem where it's on an inclined plane. Okay, so it's a slight extension of the idea, but again, it's a different context. Change principle, sometimes learning that extends existing ideas, just kind of stretching it a little bit further, also helps us in the learning process. So you don't want to sit there and say, learn this idea, oh, but now tackle this really hard, complex idea. No, you want to help kind of bridge segments along the way. Individuality principle, that just tells us everyone learns differently. Okay? Everyone has different learning styles that they bring to their own learning experiences. And social learning principle, basic fact of the matter is we learn socially. We're very social learners. We learn from observing other groups of people, or we might be interacting with other groups of people. But we're socially learning from each other in some form or another. So learning is not an isolated thing per se. Somehow you are learning from others in one form or another. So those are kind of the basic tenets, really. But again, just know that students bring knowledge to the classroom and that they need to do the work themselves. And how does this connect to developing or planning an actual learning experience that you might be doing? Well, there's kind of basically 3 roughly good questions that you can ask yourself as you're developing the learning experience. It's, what do I want the learner to know? So you have to ask yourself, what's my goal? What is the takeaway message that I need them to have? How will I know that the learner knows that idea? That's your assessment piece. How do you know that the student walked away knowing what you're hoping to know? How are you going to measure that? And what will the learner be doing in the learning process? Okay, so that's the activity themselves. So what do you hope the student to know? How are you going to know that they know it? And then what is the activity that's going to facilitate that knowing process? But to do that, you sometimes have to talk to your learners. And sometimes it's easy to find activities online or in a book and say, hey, this is going to work. That may not be enough. Sometimes, one, you have to do the activity yourself to see if it actually works the way you're hoping for. 2 is you might actually have to try it out on somebody else. Somebody who's not familiar with what your goals are. So it might be if you're developing a lesson for another undergraduate population, you might try it who is similar population. Have them try it out. Talk to them. If you're developing something for a K through 12 learning environment, go talk to students who are at that age level that you're intending. Because some ways you're going to find if you're not talking to students who at that age level you haven't spoken to for a long time or you never have, their ideas that they're bringing, the language that they're bringing is going to be a little bit different that you have to kind of take into account for. Okay? So always be mindful of the learner themselves. Okay? So let's say middle schooler, they're going to speak very differently. They're going to have a different way of thinking or a different knowledge set that you may not be intending that they would have because you're too busy thinking about what expectations you have or what your peers have. Okay? So you may have to make sure everything aligns. And so those tenets and those questions about developing that learning experience kind of connects back to the cycle process I showed previously. Okay? One, again, is being mindful of how people learn, because that's going to motivate how you're going to design that activity, how you're going to assess what that goal is that you're hoping for them to learn, in addition to making sure you identify what that goal was. So I can almost say that knowing the model of a learner, if you're going to develop your activity, make sure you first identify what's the outcome, what's the goal, what is it they're going to get out of this. Design the activity in connection, and then as you're designing that activity, think about ways of assessing, ways of measuring how that the student knows what you're hoping for them to know. And if you're thinking about designing an activity, there's kind of 3 big questions you can kind of ask yourself, kind of a framework sort of. The first is, what is it I want the learner to know? So that's the goal aspect. Okay. The next is, how will I know that the learner knows what I want them to know? And that's the assessment aspect. And what will the learner be doing that will help him know? So that's the activity piece. So just for an example of how I would populate this together. Okay. So what I want them to know, that's the concepts or learning goals. So maybe an example of a concept could be, going back to circuits again, my learning goal could be students will be able to distinguish between pictures of circuits and non-circuits. And that's going to target the concept of, for a continuous flow of electrons, there must be a complete path. So the idea of a complete circuit. And so knowing a complete circuit, maybe my goal then is if I give you different pictures of different circuits, you can tell me which one is going to work, which one has a complete circuit path. Okay?
I need to go to the interview now, Mike.
In ways,
I'm ready.
in ways you can assess that is maybe developing worksheets, or maybe you do a card sort or some other kind of activity. And then the activity could actually be the circuit building kind of idea. Okay. So with that, a few minutes remaining, are there any questions? So it's kind of a big rundown, sort of, kind of generic, but are there any specific questions you have? No? If you ever run into any questions or you'd like some more information, please feel free to email me. If you are working on an activity which does require younger students, maybe you want to talk to that elementary student or a middle schooler, let me know, because through my center I can get in contact with the appropriate people to make those connections for you. Okay? So don't feel like you're completely on your own. If you ever need any advice or tips or anything else, I'm happy to address that. All right.
Has everyone signed the sheet?